Okay, this is the continuation of the chapter approximation. So this is just another topic which is still related to approximation. Yeah, significant figures, or we usually shorten it to SF. So it says here that it is used to reflect the degree of accuracy. So yeah, so a number is more accurate when it is given to a greater number of significant figures. So what's it all about? Let's take an example of pi here. So I mentioned before on the previous chapter about pi, which is an irrational number, which also means that the decimal places like is never ending, right? It's never ending list, which symbolized by the dot 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 here. Okay, so now we can choose to state pi as 3.14, which people usually do. We can choose to write it as 3.141 or 3.1415 or 3.14159 or even 3.1.15926. Just up, it's up to you, like where you want to end it, right? But the difference here is the significant figures. So now the pi on the left has three significant figures because you have three whole number there. I mean like the 3, 1 and 4. While on the right side you have six numbers, right? Which is six significant figures. So again, let's take a look back at the and the explanation at the top. So significant figures, yeah, the greater the number of the significant figures, the more accurate a number is. So imagine if you have to times this pi with another number, let's say 2. The left side will give you a result of 6.28, while the right side will give you a result of like 6.28, blah, 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 something, something, which we all know that the more the decimal places that you have, the more accurate, right? Accurate the result. Or we can say the closer it is to the original number, original value. Okay, the real value, something like that. So for SF, actually there are 5 rules to identify which digits are significant. So the first and second one, take a look at there. All non-zero digits are significant. So that's why for this pi, we just count uh, the number of digits just like that to find this the amount of SF, right? You may think it is that easy, right? No, no, actually, it's just uh, happen to having no zero at all. So all non-zero digits are significant. So yeah, in this case, it is easy. But how if there's a zero? So all zeros between non-zero digits are significant. Okay. So take a look at the example, the first one. So the year 2020 S3 SF. So because all zeros between non-zero digits, so this zero, yeah, between the 2 and the 2 is significant, while the other zero, yeah, uh, the most behind one is not a significant figure. So only 3SF. And then for the third and second, for the third and fourth rule, and a decimal, all zeros after non-zero digit are significant. So um, actually on the screen we can see like a minor technical issue. So what I wrote there is I wrote 4560.00800. So it's decimal. Now it's 9SF. So how come? So like 4560.00800, they are all 9 digits, right? So all of them are significant. Why? Because firstly, the 0, 0 between the 6 and 8, significant because of the second rule. So again, the second rule, all zeros between non-zero digits are significant. And the last two zeros are also significant because of the third rule. So all zeros after a non-zero digit are significant in a decimal. That's why the 0 here is not decimal. I mean, not a significant figure. So for the fourth rule in a decimal, all zeros before a non-zero digit are not significant. We have also technical issue here. So hope we can still see it. So 0.0024, only 2 SF, right? Because 0 are in front of 2 and 4. According to the fourth rule, it's not significant. Okay, this might seem a bit confusing right now. Yes, you have to memorize it a bit. So memorize it and you will not be confused anymore. Or if you choose not to memorize it, you can keep practicing. Yeah. So the moment you already done so many practice for this kind of question, which is the SF question, you will memorize it by yourself, like automatically without you knowing. So as for the for the fifth rules in whole numbers, the zeros at the end may or may not be significant. Now, this is the only rule where it says may or may not, right? The four rules before is just very obvious, pretty clear on its rule, while the fifth one is kind of, may or may not be, right? Confused, right? No need to be. So let's just head right away to the example where you can understand the fifth rule just now. So round off each of the following number of significant figure as given in the bracket. So 8,982, they want you to round to 2SF, right? So step one, determine the SF, right? Starting from the left. Because they only ask for 2SF, you have to look at the second digit. Because you already know if you round to the nearest hundred, that means nearest hundred, the last two numbers will be 0, 0, right? It will be insignificant, right? So the first two numbers will be significant, and it will leave you with two significant figures. So step two, yeah, circle the next one. Same like rounding, because it is 8, which is more than 5. Oh, sorry, more than 4. 9 is rounded up to 10. So now the 89 becomes 90. Now, step 3, take a look at step 3. Put a 0 to indicate the second SF. Rule 5, this 0 is significant. Now, this is where the odds is happening. So you are you intended to make to create a number with 2 SF, right? But sadly, when you round up the 9, it becomes 10, which then produce another 0 number, right? 90. If you notice here, actually 9,000 only have one significant figure, which is the 9. The other 3 zeros is insignificant. But because the question requested a 2SF, which in this case you have no other choice but to make the 0 beside the 9, that 1 0, become significant number. So it's like you disobey the third rule, right? Which says that non-zero digits are significant, but only in decimal, yeah. But there's the fifth rule that says it is allowed. So the question still makes sense. Yeah, think of it as like insurance. So you intended to make 2SF. Accidentally, you can only make 1SF, and then there's fifth rule coming here and says to you, no problem, I got it all covered, something like that. Okay, and then step 4, put 2 zeros as placeholders. Yeah, step 4 is just uh, asking you to make it clear that those two are insignificant or not significant. So for question B, 4SF, yeah. So all the zeros on the left not significant. So you need only the 6019. So the number behind the 9, which is 5, yeah, is as the indicator, yeah. Whether you need to round up the 9 or round down. Because it is 5, you need to round up, will become 6020. And you don't need the fifth rule here. It's almost the same case with the A, right? But you don't need the fifth rule. Why? Because it's decimal. It's in decimal, it's already allowed to be significant for this last zero. Okay? So and then for number C, yeah. Okay, it's just normal. So you can see it by yourself, and then it's the end of this discussion. I'm gonna see you on the next discussion.